Hi, we're going to be talking today about a workflow for using APIs in kind of larger projects and introduce some techniques for kind of checkpointing and storing data along the way. So so here we go. Here's the Jupyter Notebook. The one thing that I suggest this sort of 3-step workflow. Each of these steps may be broken down into sub-steps, but you're going to write code that gets data from an API and saves as much as possible to a file. I really want to underscore this one. In this example, I actually wish that I had done this a little bit better, but you should, when you're getting data, when you've set all your stuff up to get this, all of the data you think you might want from Reddit or Bluesky or wherever you're getting this data from, think carefully about things you might possibly want in the future and be really generous in what you collect. So get all of the metadata fields that you think there's any chance you might want. Get all of the data you think there's any chance you might want, right? So, if there's, be really generous in the query that you use or the communities you include. Think of things that you might possibly want in order to make, if you want to change your analysis. And the reason for this, I talk about this a little bit in, kind of in this paragraph here, is that like sometimes you won't be able to get that raw data again, that the API has changed, or they only have a window for which things are available, and you can't get it anymore. And so storing data as close to the raw data as possible. So this might mean writing things out in JSON to a file. This might mean just being really verbose or really, generous, really, what's the word I'm looking for? Anyway, really generous in thinking about the fields that you want to capture and writing them to a CSV file, etc. So that's the first step. Second is to write some program that extracts the data that's going to be useful and then and puts it in a CSV. Sometimes this might mean combining things that you've gotten in different places. And then program number 3 loads the CSV and does analysis. And this is the one that's often broken up into other pieces as well, right? That you may create some measures, right? Maybe you have measures of the the average toxicity of someone, or measures of the number of posts per week that they make, right? And so you'd have these kind of aggregate measures. Maybe you have something that measures even a deeper psychological construct, what's the proportion of I-we language that they use, et cetera, right? Like you can imagine lots of things where we take this sort of raw data and create some measure that is important for the research questions we care about. And then we do some sort of analysis, right? So this, again, might be multiple steps. There's a step that creates the measures. Maybe you're creating figures, and maybe you are doing a statistical analysis, etc. I show some very simple versions here. Often, for me at least, these will be in different files. For me, usually Python files instead of Jupyter Notebooks, but they can be Jupyter Notebooks as well. But you often want to kind of break things up as well so that it's not just one gigantic file that's doing everything. Okay, so I talked about the one benefit, saving the raw data so that you can change your analysis. If you decide you don't want to come and think, oh, I wish I just got the who the author was. I got whether they reposted something, but I don't know who the original author was. Why didn't I get that? Just get everything, even if it's gigabytes. Like text data does not take it that much, and so you can be really liberal in that's the word I was looking for, really liberal in what you collect. Okay, this also gives you a nice pipeline with intermediate files. So I have this, you'll sort of learn from my past mistakes. I had a project where I really sort of went from raw data all the way through to my measures, not quite analysis, but to measures, and just I had one file that took raw data and really turned it into these made networks and created measures from them. So it sort of did everything, had all these steps, and it was sort of a black box, right? That it was hard to, I made some errors and I had some bugs, and it was really hard to detect them. And so having a pipeline that does each step on its own can help to find bugs. It can also help, instead of if something goes wrong, you don't have to start from the raw data and do everything. Sometimes those steps are computationally expensive. You can go to wherever the bug was and just go forward from there, if that makes sense, and not have to do the difficult bit up front. Okay, that's especially true of going back to the API. Even if you can get more data, that's the part that often takes tons of time, and you just have to wait and wait. Okay, so we're going to use the Bluesky API using the @proto library. It is, I'll make a quick caveat. I noticed on their website that it says that it's unstable, that they don't guarantee that it'll work the same. So hopefully this works by the time that you get this. Yeah, and there we go. So our big research question is, what are the main groups of people who post about Purdue? So we're going to get the last 1,000 people who posted on Bluesky and include the word Purdue. They'll grab all of their recent posts, cluster them based on who follows who, and use TF-IDF, which is a simple computational text analysis technique, to identify the topics of discussion for each cluster of people. So we need 3 main pieces of data: the last 1,000 people, the recent posts from those people, and a follower network of those people. So we're going to save those each to a separate file so that we could mix and match and change those. So let's start here. So this loads the proto library, and then you'll also need this Bluesky _auth.py file in this same directory. And it should have capital username equals, and then as a string, your username, capital password equals a string of your password. And that will log you in, or log this client in. Okay, so we're going to get all the recent posts that mention Purdue until we have 1,000 unique posters. This is very similar to what we did in the last exercise. Hopefully it looks familiar if you saw that one. So we're going to, we have this get posts function that gets 100 posts at a time. That's what this n equals 100. And then returns those. So this is using these parameters, gets 100 things that have this query. It's going to be Purdue in our case, and returns those. And then we're going to get 1,000 of those. So we'll create a set of posters, or sorry, not 1,000 posts, until we get 1,000 posters. And so we're going to open a file, recent Purdue posts.csv, for writing. And we're just going to, as we get these, we're going to write out all of the posts. This is the field names we're going to get. We're going to get author, text, like count, repost count, the URI. This is the Universal Resource Indicator. Anyway, it's a long string that represents where this post lives, and a timestamp for when it was posted. There are other fields. This is the part. I wish that I had put more in here. Look through the API documentation and think about anything you might possibly want, and just grab it. You might as well. But for now, we will use these. So we're going to create this writer, this dictionary writer from the CSV library, and write the header. And then we're going to set a counter. Our cursor starts at none. Excuse me. This tells the API how far to go to, pagination, basically. We've already got the first n. Give me the next 100. Okay. So a response. So we're going to do this loop, right? We're going to use that function we just wrote, get things that have Purdue in the post somewhere, and then update our cursor to get the next one, the next time we go through the loop. And then we're going to loop through all of the posts that we get. We're going to, just say that, oh, wait a second. I don't want to do, oh yeah. Yeah, that's fine. Okay, so every time we'll check and see, that's not true. We don't have that many unique posters. Oh yeah, that is true. Okay, we'll have that many posters. So anytime we've gone through 100 posts, we check how many unique posters we have and update. We could do that a different way. There's probably a better way to do it. That's fine. That'll work. If the author is not in our poster set already, then we add them to our set. And again, yeah, I put in a comment as well. Save as much as you think you might possibly want. We're going to write this out. So we're going to write out the author, the text, like count, repost, URI, and the timestamp. And then we're going to check. Again, there's probably a better way to do this. We just check it twice. So if the length of the posters is we could just say equal, but greater than or equal to 1,000, then we're going to break out of this loop. And then we check the same thing here. If it's greater than or equal to 1,000, we break out of our while loop as well. So let's run this. Oh, I thought I cleared the other. Let's see. Did I not clear the other outputs? Let's clear all the outputs. That one worked. That should have worked. Let's check in, make sure. Yeah, great. Looks great. So we have this author. There's likes and reposts and our URI. Looks like everything's there. So that's great. And now we have it in a file. And you can see, like, that was pretty awesome, right? That was pretty great. In fact, let's look at the DF. It's so quick. The Bluesky API is really nice, really fast. Looks like 2,200 rows before we got to 1,000 unique authors, which seems reasonable. That seems reasonable. And now we have it in a file. It's great. We got our 1,000. But unfortunately, other things will take more calls than that, right? That's a pretty simple one, as we will see in just a second. So, okay, so we're going to do this second one, which is we have those 1,000 people or 1,000 users. We're going to get recent posts for them. So for each, we'll do the same thing. This looks almost identical, right? But instead, it's using this get author feed method. So where we're going to give it an author name, and it's going to put them together into their posts, the post for that person. We are going to do things a little bit different. We're going to tell it how many we want. So the default is 100, and it will do in the function, it takes care of the response of the cursor, resetting the cursor, and looping until it hits at least this many, 100 posts for each person. So we're going to read in the recent posts that we have. We're going to get a set of all of the authors, so this should be 1,000. We're printing it just to make sure that's right. And then here's the key idea. This is called checkpointing. So what we're going to do is try to open our output file. This R means we're opening it for reading. And then we're going to read it and make a set of the posters of the people who posted in our output file. If it doesn't find it, then that set is empty. We'll make an empty set. Then, after we've done that, we're going to open the file again, but this A means append. So if it's empty, we'll append from the top. If it has stuff, we're just going to add stuff at the bottom. And importantly, we create a dictionary writer here, and tell it the field names that we're going to get. We are going to set a counter for how many we've already got. And then if it's 0, if there's nobody, if it's an empty set, in other words, the file doesn't exist yet, we're also going to write a header. So, and that's just going to write this string at the top, the field names, as a CSV. Okay, so if our poster, here's the checkpointing part. Here's the part that's cool. If it's already in our list of retrieved posters, then we're going to skip them. We'll just continue to the next person, right? So we're just going to skip right past. Otherwise, we'll get all the posts for that person. And for each item, we're going to do the same thing. We're going to write out the poster. So this is the person who we're getting their post from. And I realized, again, this is, this happens as you look at the data. This might not be the same as the author. So if they reposted something, then the author and the poster might not be the same. And so we get the poster and the author, the text, like count, repost count. You're right. In this case, there are some things you can do with the API. So for example, you can filter to only original content, right? The things that they wrote and not the things they reposted. In this case, we want to cluster people by interest. And so I think it makes sense to me that we would include everything that they reposted or wrote themselves and kind of group that as sort of their interests. But you might decide something different. And that's, you could also write a filter in here for, for ways to, filter things, etc. So, but that's what we're going to do in this case. We're going to just tell it, update with how many we've done so we can see the progress. It's actually pretty quick. It was quicker than I thought. There are 1,000. That's good. That part worked. Uh-oh. Something didn't work. Oh, I know it didn't work. I already had that file. So I'm going to delete it real quick so that we can start over, which is a bummer because it takes a little while. I'm going to delete this one. Posters, other posts. Okay, and we have recent Purdue posts. That's the one we already have. Okay, so let's hide that again. And let's try running this again. So they're 1,000, that's great. Okay, so it's finished 50. And I'll pause so you don't have to wait with me, but I did want to show, once we'd at least made it to some, like what this looks like. I'll stop right after it gets to 100 and then show what the checkpointing looks like. Okay, so we made it 100. Let's say something goes wrong. Your computer shuts down, your internet shuts down. So we'll stop it. And then in theory, hopefully, when we restart it, we get to 1,000 and it will very quickly tell us that it made it through the first 100, hopefully. Yeah, perfect. It didn't even tell us. Oh yeah, because we only we continue before we get to the condition, but we've already made it to 150. So just flying right through. Okay. Well, while that's running, maybe we'll come back to it, and I will tell you what's going on after that. So we have this follower network. We're gonna get the who people follow. So we have 1,000 people. We're going to see who they all follow. We are going to make sure it doesn't take too long, we'll set a cap of 5,000. So 5,000 of the people that they follow, that's a lot. Not many people follow more than that. And so that should get most of them. And then our goal is to eventually look at who follows who among that network. But we're going to start off getting all of the people that they follow. And so that's what, let's run through this code. So get all followers. This looks just like what we've done before, right? We have a cursor. We have this sort of empty list that we're going to add to. And then we get a response. We have a limit. We have the cursor. And then again, if the follows is greater than the max follows, then we're going to break. Otherwise, we'll just keep going. We'll keep getting more and more of the people that they follow. Okay, we are also going to do some checkpointing here as well. This one takes a while, so we're going to get the posters, our 1,000 people from the recent Purdue posts. We are going to then do the same thing that we did up above. We're going to try to open this and get the retrieved posters. If it doesn't exist, then it'll be an empty set. Okay, so now we are going to go through all of the posters. Right? Oh yeah, we'll do the same thing up above, sorry. We'll write a header if there's no one in the retrieved posters. Otherwise, we'll just keep going and append. So we're appending again this A. So for each poster in the posters, if they're in retrieved posters, in other words, if we already got the follow network, then we'll just continue. Otherwise, we'll get everyone that they follow, well, up to 5,000 people. And for each person in that, in that group, we will write a from and a to. So the from is the person themselves, and the to is the person they follow. So a directed network from this person to the person that they follow. And then we're going to update. This adds, so this is one that can take a while. It can hit rate limits. And so every 50 people, we will pause for 20 seconds to make sure we don't hit rate limits. Let's check on our guys up here. We've made it through 700 in about 3 minutes, 750. So I'll pause my video now, and then we'll come back in a second. Okay, the cake is out of the oven. It took about 4 minutes total, so not too bad. We got all 1,000. Let's take a look and make sure it looks okay. So we have poster, author, the text, like count, repost count. Let's scroll a little. Problem with zooming in so y'all can see. And the URI. It looks great. I think it's everything that we need. Again, and it is 117,000 rows. Does that make sense? Yeah, I think that makes sense. We had 1,000 people and 100, at least 100 posts per person. So sometimes it will end up getting more like 200 per person for some people, right? Depending on how many it returns. In the first time. So yeah, that seems possible. Okay. Sorry, I got distracted. The thing I was going to say, just add all the fields you think you might possibly want. Look through the API documentation, think about the things you might want, and add it all. Okay, so our follower network, we went through how this works. I'm going to start running that. And this one will take longer. Let's see how long it takes to do 50. That'll give you a sense. And then I will just let it run, and we can come back. We'll do the same sort of thing. We'll look at this. In fact, I'll look at the whole thing because I want to see the dimensions, and the printing works pretty good. But I'll walk you through what we're going to do after it's done, which is this part right here. It's pretty darn simple. How long did it take? I don't remember how long it took me when I was looking at it before. Oh, there we go, 50, just over 30 seconds. And again, this also makes a big difference for, if you happen to get a bunch of people with only 100 people that they follow, then it will fly right through. But if it's a bunch of people with 1,000 people or 2,000 or 3,000, then it'll take a while. Yeah, we can make sure as well that this is working. That our checkpointing is working. Here, let's just take a quick look. Yeah. All right. Well, let's just pause there. That should be close to 100, so it should get to 100 really pretty quickly. Let's see if it does when I stop and restart it. Thanks for waiting along with me. Okay, there we go. I made it to 100. That looks promising to me. So we'll let that run, and I'll walk through what the next little piece of code does, and then I'll probably have to pause and come back to it. Okay, so what we're going to do is we're going to load this again. We called this follow network, right? It's a directed edges of who follows who, and then we are going to filter it just to the people where the two. We know all the froms are the from. Are all of our posters. It's 1,000 posters. It should all be there. And then the two we're going to filter to also just the people who are in the posters. So we'll do that, and then we'll save that as another CSV. Again, this is nice to have these intermediate files that you can compare. For really, really big data sets, this is often not practical, right? But for something like this, I think it's nice to have these sort of sequential intermediate data sets. Okay. Finally, what we're going to do, I'll kind of walk through this and then I'll show you what it looks like, is create a network from that. So we're going to use the network X library, and then we're going to read in the CSV, create a network from the pandas edge list, and then use a community detection algorithm. This is the greedy, I think it's also the same as the fast greedy in R or in iGraph, but a greedy modularity community detection algorithm, and then you will print out how many communities each one has, and then make a picture of it and use TF-IDF. So let's see how we're doing up here. Oh, we've only made it to 200. Okay, I'll pause, I'll let that finish, and then I'll come back. All right, I'm back. 16 minutes, that's fine. It's not that long. It was lots of things. Sometimes I've had, things running for days. So 60 minutes isn't bad, but it gives you a sense, right, of kind of how long this sort of thing takes. It's a lot of calls. For each person, we had 1,000 people, maybe on average, right? Let's say they follow 800 people or 900 people. That's 8,000 calls, so it takes a while. Okay, so let's take a look at this. That looks good. We have from and to. We have, 596,000 follows. And again, actually in an earlier version of this, I did a filter where I only filtered at this point to the people who are in both, who are part of the posters. But I think it's nice, right? You can do things here, like look at the distribution of how many people follow, etc. You might want to look into some of their, take a random sample of their follows or something like that. And so there's other approaches you could take because we saved all of the data instead of filtering it. And now we can filter it here, right? That's the easy part. Oh, and sorry, I opened this. Is that right? Let me see. Let's see how big it is. It is, 27 megs, which is, right, that's a lot of data. 596,000 rows, but it's only 2 columns. So yeah, that's nothing to worry about, right? You don't need to worry about trying to, save your computer from having an additional 27 megabytes. So, okay, so let's filter this to our filtered network. This will be much smaller. It's just the people that are in both. And now let's run this. So we're going to get our communities. We have, okay, here's our communities. It sorts them by size. So we really have like 4 main communities, 3 main communities. Oh yeah, 4, sorry. It's 0 index. 4 main communities and then a bunch of little ones. We can look at what that looks like. I'm not going to, really go into this. This isn't about using Network X, but this is going to use the Spring layout and color them based on the community that they're in. It'll take a minute, but not too long. So there we go. So as you can see, it's really sort of one big community. We call it 2, but it looks like kind of, if you squint, the right-hand side is sort of one community and the left-hand side is sort of one community. But let's look at what they're talking about. So we are going to use TF-IDF. The basics of this, in a future lesson, we're going to talk about computational text analysis and TF-IDF in detail. So I'm just going to mostly skip over it. But what we're going to do is we're going to load in the post that they had made, right? We're going to, I realize that NAs mess things up, so we'll change that to empty strings. And then we're going to, here's the important bit, for each community, right? So these communities, let me show you what they look like really quick. It just is a set of these usernames, right? So community 1 is these people, community 2 is these are the last ones, I guess. These people, etc. So that's what the communities are. And so we can do things like filter their posts based on them being in the community. And we're going to get the text from all of those and join them together into a giant string. So basically we'll have one giant string or a document in computational text analysis terms for each community. And then we're going to fit those. We're going to make a matrix of all of these that gets and then get the feature name, in other words, the words that are most associated with each community. I like to admit I've not done TF-IDF stuff for a while. I used Copilot to help me with this, but I'm pretty sure I'm telling you the truth for what it's doing. Okay, so then we're going to go through the communities. We're going to skip the little ones just to make it easier to read, and because it's like, is this really people who talk about Purdue if there's only 2 of them and they just follow each other? But we're going to print the top words for each person. This is going to be the end of our analysis today, or the top words for each community. So this one, it has com and www, so they're more likely than some of the other communities to share URLs. Trump, again, a URL, people, social, news, Epstein, state, Dawn. So this is news related people who are maybe sharing things about the news, etc., but broadly general, maybe semi-political. And my guess is this is like they're also sharing Purdue sports or Purdue news as well. This one, let's look at this one. Let's look at it as a scrollable element so we can look at more. The next biggest community, Michigan, just like game, Iowa, let's see, team, people, football. So this one definitely seems more like Big Ten and sports. So more sports related. What have we got here? Nebraska, Huskers, Gaming Juice, Nebraska Cornhuskers. So maybe, I don't know, basketball. Maybe this one's slightly more football and this one's slightly more basketball. I don't know. But it seems pretty similar. So also sports. This one seems like maybe more, like, see, Palace, social, philosophy, maybe more research, right? University research, so more academic. Brewer Fanatic, ESPN. So this is another sports one. So lots of sports. Again, maybe not surprising, right? What do people talk about on social media and on Bluesky? Maybe also sports, civic accountability, and citizenship, maybe. And then a Spanish one. So yeah, so there we go. So there are clusters. these sorts of things, it's maybe more, I mean, another helpful thing might be to look at the most prominent posters in these, but this does give us at least something kind of interesting. If by chance, this looked, Purdue might be something where most of the conversations are about sports, but maybe we had another topic other than Purdue, and maybe that's a good exercise for you, is to choose another topic and just run through the same thing and do your own analysis of that. Other than Purdue, I'm trying to think of something that might be more, you might do something like polarizing, like Trump or guns or something like that, where you'd expect to see sort of more of a bifurcation. But there you go.